Hey, this is Unit 1 notes covering domain and range word problems. So we have to read each of the word problems and then answer the questions below. So for the first one, it says, Joe had a summer job that pays $7 an hour, and he worked between 15 and 35 hours every week. His weekly salary can be modeled by the equation S equals 7H, where S is his weekly salary and H is the number of hours he worked in a week. So for the first part, it says describe the independent variable. Okay, independent variable, when we think back to that, is the variable that does not depend on anything else. So our independent variable is always going to be our X variable. So I'm going to do, this is like our X. And I'm going to put over here, doesn't depend on any other variable. So if we remember our standard linear equation of y equals mx plus b, notice that our x value is after the equal sign. So if we were comparing our s equals 7h, our quote-unquote x value, our independent value, would be that h. And we know that h stands for hours. And not only does it just stand for hours, it's the number of hours he works in a week. So the number of hours Joe works per week. Okay. So now we're going to find the domain and range. So again, we said our independent variable is H. Independent means our X value. So our hours is going to be our domain. So this is hours, and then that means our salary is our range. So for domain, for his hours, it says he can work between 15 and 35. So between 15 and 35. And we are going to include those values, but because he can work 15 and he can work 35. So in order to find our range, our salary, we have to look back at the problem and see how much he makes an hour. So he makes $7 an hour, which means I need to take my 15 and my 35 and multiply it by 7. Okay, so in order to find this range, I have to do 15 times 7, which gives me 105, and 35 times 7, which gives me 245, which means he can make a minimum of 105 and a maximum of 245. Now it gives us an ordered pair of 20, 140. And we have to determine what this means in context to the problem. So 20 is our X value, 140 is our Y value. We know our X value is the same as saying our hours, our H, and our Y value is our salary, which is S. So 20 is the hours he works, and 140 is the amount he makes. So when Joe works 20 hours, he makes $140. Now let's look at the next problem. We have Hector Service Club is raising money by wrapping presents in the mall. The function S equals 3P describes the amount of money in dollars the club will earn for wrapping P presents. They only have enough wrapping paper to wrap 1,000 presents. So in number 4 wants us to describe the dependent variable. So remember, we said the independent variable was our X value. So our dependent variable is going to be our Y value. If we remember, y comes before the equal sign in a linear function, that means our corresponding y value is the S. And we know S stands for the amount of money. So the amount of money Hector earns. Now it wants us to describe the domain and range for this. So remember, we're saying our dependent variable, our y, is our range. So the amount of money Hector earns is our range. Okay. So this is our money, which means that our domain is the amount of presents he wraps. So P, the amount of presents he can wrap. So if we go back to the problem, it says they only have enough money, they only have enough wrapping paper to wrap 1,000 presents, meaning they could wrap 0 presents and they can wrap 1,000 presents. They can't wrap less than that because you can't wrap negative presents, and they can't wrap more than 1,000 because they only have enough wrapping paper for 1,000. So now looking at money, we have to go back and look at their equation here. So their equation up here is that S equals 3P. S equals 3P. So the amount of money they make is 3 times the amount of presents that they wrap, which means that they are charging $3 per present. Okay, so if they're charging $3 to wrap a present, if they wrap 0 presents, they're making $0. But if they wrap 1,000 presents, 1,000 times 3 is $3,000. So they can make a maximum of $3,000. Okay, let's look at the next one. It says the surface area of a cube can be found using the following formula. A equals 6s squared, where A is the surface area and S is the length of one edge. Your geometry teacher wants you to draw a cube that has a length of at least 5 inches. Okay, so for number 5, it wants us to find the independent variable. So the independent variable is the one that doesn't depend on anything. So that is our x variable. And in this case, x comes after the equal sign. So that would be our corresponding s value. And we know that s stands for the length of one edge. Okay. So when we're finding our domain and our range, we know that x is domain. So s, that length, is our domain, and our range is the surface area. Okay. So for domain, if we look back at the problem, it says your geometry teacher wants you to draw a cube that has a length of at least 5 inches. At least 5 means that's the minimum. Has to be at least 5. But it doesn't give a maximum value, meaning you can have a length of a side of a cube to be as large as you want it. So all the way to infinity. Okay. And then if we were to find the range, we would have to find that corresponding surface area. So we would plug in 5. So we have A is equal to 6s squared. We would plug in 5 for s. And so we have 5 squared, 25. 25 times 6, 150. So that means our minimum surface area would be 150 inches cubed. And then our largest one would be infinity. Number 8 says, find an ordered pair that represent a reasonable input and output for this function. Okay, so we need to pick an ordered pair where if we were to plug in that s value, so the length of one edge, we would get the corresponding surface area value. So we could pick 7,294. Okay. This is the same as saying f of 7 equals 294. So when the length is 7 inches. The surface area will be 294 inches squared. So all we did is we found a number, for example 7, and we plugged it into our problem for S and got our value of A, which was 294. Okay, last problem here. We have a ball was thrown into the air with an initial velocity of 72 feet per second. The height of the ball after t seconds is represented by the equation h of t is equal to 72t minus 16t squared. The graph of the function is shown to the right. So first it wants us to describe the dependent variable. Okay, the dependent variable is our y, quote unquote y. And if we were to look at this graph, our y-axis is always the axis that's on the left. So in our case, that is height. So our dependent variable is h equals the height of the ball. Then it wants us to describe the domain and range. So looking at the domain of this function, so from left to right, okay, we see that the ball starts at 0, okay, so that's the amount of time and the height that the ball starts with. So if we haven't thrown the ball hasn't reached a height, and we haven't started our time. And then it goes all the way to about 4.5 seconds. So it would be 0 to 4.5. Oops, and we're doing brackets on both ends because we can include times that are 0 and we can stop a time at 4.5. Okay. Next one, it wants us to look at the range. So when we have not thrown the ball, our minimum value is 0. Okay, the ball has not left your hand, so it is at 0 height. Then we look at the maximum. So if we go look at the top, it looks like the maximum that the ball reached was about 81, 82. We got to take a educated guess there because it's not on an exact point. So I'm going to say that the range was 0 height from the beginning, and it got all the way up to about 81 feet. So that would describe the domain and range of that function.